So let's continue on with this problem right here. We have 2x plus 1 raised to the 45th power. Again, this would be impossible to expand out. Well, not impossible, but it would take forever. So again, you're saying let u be the inside, which would be 2x plus 1. Then remember u prime, which is du dx, would be the derivative of 2x plus 1. We already decided the derivative of 2x plus 1 was 2 times 1 plus 0, which is just 2. So then you would know that this is really u to the 45th power. That's your original function. So that would tell you that the derivative of the function would be 45 u to the 44th times u prime. Never forget to do the derivative of u. When you back substitute into this, this would be 45 times u. Well, u was the 2x plus 1 raised to the 44th power. Never, ever, ever forget to multiply times u prime, the derivative of the inside, which is 2. So this would be 90 times 2x plus 1 raised to the 44th power. There's our derivative right there. I want you to take a step back real quick. I want you to think about what we were able to just do right there. Remember what a derivative is. Always remember the definition of a derivative. A derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. Imagine doing this problem using the limit process. You'd have to expand something out to the 45th power. Absolutely ridiculous. Imagine doing this using the product rule. You'd have to expand it out 45 times, multiply it out. Absolutely ridiculous. Same thing if you just FOILed it out and didn't use the product rule. You'd still have to multiply this out. It's absolutely ridiculous. We were able to do a problem in a matter of seconds that would have taken us hours, if not days, pages and pages of writing if we had to do it out the other time. So you really, really should respect the power of these rules. Nice and easy makes it much, much better for us to do. Okay. So there's the derivative right there. Again, as I get a little more advanced, let me show you what notation I would have written. I would have written the f prime of x. This is on my test personally. I would have dropped the power, kept the inside exactly the same to the power minus 1, which would be the 44th. But then I always remember that I have to multiply times the derivative of, this is horrible notation. This is not mathematical notation. This is Nathan notation. I have to multiply times the derivative of the inside. So I use that little parentheses there, right? That's the derivative rule. I'm saying I still have to find the derivative of that. And remember, the derivative of that is 2. The derivative of 2x plus 1 is 2. And that would have jumped me right to my answer, 90 times 2x plus 1 raised to the 44th power. Am I okay with you doing it like that? Yeah, I'm okay with the black way or the blue way. I'm not going to do it back the first way that we did it, which is the official chain rule problem, which is find dy du and then du dx, and then multiply them together. Effectively, that's exactly what we did right here. Here's dy du, here's du dx. We multiplied them together and we simplified. So we are using the chain rule. The blue way is just the lazy, quick way of doing it. Let's look at example 3. It says find the derivative of y equals x cubed plus 1 quantity squared. So if we were to find the derivative of this, we could use the chain rule. Well, it tells us we have to use the chain rule, so I'd go ahead and do that. Remember, if this were on the test and it didn't say using the chain rule, since this is such a small power, you could just technically go ahead and square this out. FOIL this out, distribute it, and then find the derivative of the polynomial. In fact, that wouldn't be hard at all to do. But this one does specify that we need to use the chain rule. Remember, on the test, you have to show your work, no credit. And if it says use the chain rule and you don't use the chain rule, even if you get the right answer, I cannot give you credit. So you have to read the problems. You have to use the method that it tells you to use. Okay, so let's use the chain rule. I'm going to do it both ways. I'm going to make the inside function u. Whatever's on the inside is going to be u. So I'm going to let u equal x cubed plus 1. So what would my u prime or du dx be? Well, the derivative of x cubed is 3x squared and the derivative of 1 is 0. So u prime would just be 3x squared. So now we rewrite y in terms of u. So this would be y equals, instead of x cubed plus 1 squared, this would really be u squared, right? Now we're going to find the derivative of y with respect to u. Well, the derivative of u squared would be 2u to the first power. But then we need to multiply it times du dx, which our notation is just u prime. Never forget that u prime. So if we do that, we would have 2 times u. Well, u was x cubed plus 1 times u prime, and u prime was 3x squared. Let me do some highlighting here to help you see where I pulled those from. So again, u is right there, and u prime is right there. That's where I'm pulling those things from. We can clean that up a little bit. Well, we can clean it up a lot a bit. So 2 times 3x squared would be 6x squared. 6x squared times x cubed would be 6x to the 5th power. Again, 2 times 3x squared is 6x squared, and then 6x squared times 1 would be the 6x squared. If that took you multiple steps, don't be ashamed. Please, by all means, take multiple steps to do that. So I could have seen it written in this form. If you left it in the form of 6x squared times x cubed plus 1, I would have been perfectly fine with that answer as well. I don't care. Any of these answers would have been fine. Any of these, let me be clear, any of this answer or this answer, either of those two answers underlined in purple, which is the 6x to the 5th plus 6x squared, or the 6x squared times x cubed plus 1, either of those two answers are perfectly acceptable. Let's move on to, let me go ahead and do that now. And the blue way, the kind of more advanced way when you get comfortable with it. Looking at this problem, if I was finding the derivative of y, what do? Drop the power, keep the inside the exact same to the power minus 1, which would be the first power. But then I've got to remember to multiply times the derivative of the inside. Never forget to multiply times the derivative of the inside. Well, the derivative of the inside, the derivative of x cubed plus 1, was 3x squared. So this is where I would have seen 3x squared times 2 is the 6x squared times x cubed plus 1. That would have been my final answer right there. So drop the power, inside just the same, power minus 1. That's our power rule, right? But remember to multiply times the derivative of the inside. Either of those ways, the black way or the blue way, would have been acceptable on the test. I would have accepted them. Let's go ahead and look at example 4 on the chain rule. Again, remember, this is really y equals, let me get the right color. Y equals x squared minus 3x plus 1 raised to the 1/2 power. That's what we're dealing with here. Anytime you have a radical, you want to change it into exponential form so we could use the power rule to find the derivative. Remember, u is always the inside of the function. So in this case, u would be equal to x squared minus 3x plus 1. So that means du dx, which is u prime. Take the derivative of that with respect to x. The derivative of x squared is 2x. The derivative of minus 3x is minus 3 times 1, which is minus 3. And the derivative of 1 is 0. So we'd have 2x minus 3 is u prime. So then we would say, rewrite y in terms of u. Y would equal u to the 1/2. And so if I want to find y prime, which is dy dx, I'd find the derivative of u to the 1/2, which would be 1/2 u. But then I need to multiply that times the derivative of u with respect to x. In other words, multiply that times u prime. Never forget that u prime. Now we're going to do our substituting. We're going to back substitute in for u. We're going to back substitute in for u prime. Let's see what we get when we do it. We'd have y prime equals 1/2 times, well, it would be, I messed up the power. The derivative of u to the 1/2 is 1/2 u to the negative 1/2, right? I've got to be really, really careful with that. And then we multiply it times u prime. So this would be 1/2 times x squared minus 3x plus 1 raised to the negative 1/2. And then we have to multiply that times u prime, which is 2x minus 3. Cleaning that up, what stays on top would be the 2x minus 3. What goes on bottom, we have the 2 from the 1/2. And then when we throw that x squared minus 3x plus 1 into the denominator, that makes that exponent positive, right? We can't have that negative exponent, so I have to throw it into the denominator. And I also realize that it started as a radical, so it needs to end as a radical. So to the 1/2 power is the square root. So this would be the square root of x squared minus 3x plus 1. So that would be my derivative right there. 2x minus 3 all over 2 times the square root of x squared minus 3x plus 1. Again, let's do this a little more advanced. Here we would have the y prime. If we do this the other method, drop the power, keep the inside exactly the same to the power minus 1. That would be the negative 1/2. times the derivative of the inside. So I'm going to write that x squared minus 3x plus 1. The derivative of that, well, the derivative of that would be 2x minus 3. And that would give me my answer. The 2x minus 3 would stay on top. The 2 would be on bottom. We'd have, I don't know why I put a parentheses, we'd have the square root of x squared minus 3x plus 1 on the bottom. So either of those methods again, the full-on u substitution where you can see that we found u, we found du dx, we put y in terms of u, so we found dy du and du dx. So we multiplied those two things together, simplified, and that got us our answer. So if you're more of a traditionalist, which many teachers are traditionalists, they want to see the full u substitution process. I will tell you this full u substitution process is very important when we come to anti-differentiation. So even if you get a little lazy like I do and start doing the blue quicker process, you do still need to remember the u substitution process, because we will be using that when we towards the end of the semester when we find antiderivatives.